Hello student, let's try to understand a very good problem. A welding fuel gas contain carbon and hydrogen only. So element are there, carbon and hydrogen are there. Burning a small sample of it in oxygen gives 3.38 gram carbon dioxide. So if you are burning in the CO2 oxygen, it will give CO2 and they are giving 3.38 gram. And 0.690 gram water. So if you are treating with the H2, suppose 1 by 2, here you can say that is H2O. So 0.690 gram and no other product form. A volume of 10 liter measured at STP of the welding gas is found to be to weight 11.6 gram. Calculate empirical formula, molecular mass of the gas, molecular formula. These things they are asking, dear student. So first of all, empirical formula, since they are asking empirical formula, so we should know the percentage mass, student. Percentage mass. So percentage carbon, what will be there, student? Mass of atomic mass of carbon, molar mass of CO2, molar mass of CO2 and the mass of OC form, mass of CO2 formed. So here you see atomic mass of carbon 12, molecular mass of carbon dioxide is 44 and mass of CO2 form is how much? 3.38 gram. So how much answer you are going to get, student? 0.9218 gram. This is percentage carbon you got. Percentage hydrogen, student. So molecular mass of H2, molecular mass of H2, this is then molecular molecular mass of H2O multiply by mass of H2O form, mass of H2O formed, student. So molecular mass of H2 is 2, molecular mass of water is 18 and mass of H2O form is 0.690. 0.690. So dear student, how much is coming? 0.0767 gram. This is for the hydrogen. So these two things we got, student. Not the percentage, these are the amount, student. Amount, how can you say percentage? That is amount of carbon. Amount. This is the amount of carbon and amount of hydrogen. Now, if you see the percentage of carbon, so for percentage of carbon, if you are calculating, so that is mass of carbon divided by mass of carbon plus hydrogen multiplied by 100. So mass of carbon you have calculated 0.9218 divided by 0.9218 plus 0.0767 multiplied by 100. So student, how much is coming? This is 0.9218 divided by 0. It is going to be 9985, student, multiply by 100. So the answer is coming 92.32%. This is the percentage carbon, student, right? Now percentage hydrogen easily you can calculate by subtracting from the 100. So either you use the percentage hydrogen is equal to 100 minus percentage carbon, 100 minus percentage carbon. So 100 minus percentage carbon 92.32. So it is going to be how much, student? 7.68 percentage. Or the other way also there, student, for calculating percentage hydrogen. So percentage hydrogen, mass of hydrogen divided by total mass multiply by 100. Mass of hydrogen, student, how much you got the mass of hydrogen here? 0.0767, 0.0767. Total mass, student, just now we have added these two, so 0.9985 multiplied by 100. So on subtracting it is solving, student, 7.68% it is coming. So the percentage of both the substance we got, student, carbon and hydrogen. Now for empirical formula, what do you do? For empirical formula, empirical formula, student, what you can do for empirical formula? So element you are writing here, you see element, then percentage mass, then number of moles. So number of mole, then it will be simple ratio, student, simple ratio. Okay, then it will be the empirical formula. Now here you student, you see what are the element carbon is there. So carbon is the percentage mass, just now we have calculated. This is the percentage is there, 92.32. So 92.32, it will be its gram mass also, and hydrogen is 7.68. So number of mole you are calculating, so given mass 92.32 upon 12 molar mass, and here is how much it will be there, student, 7.68 divided by hydrogen atomic mass is 1. So the here number of mole is coming how much, student? The number of 7.69, and here is 7.68. So if you are, this is the ratio, student. Actually number of mole is there, but if you are calculating, here I am writing 7.69. This is also 7.68. So you need to divide by the small whole number, 7.68. So it is going to be 1, and 7.68. This is also going to be 1. So empirical formula, if you are writing empirical formula, so it is going to be C1H1. This is empirical formula. So one thing we got to know. Now for molar mass of compound, so what we can do for molar mass of compound, 10 liter of the gas at HTP, how much they have given, student? 11.6 gram. It is there in the question itself. Here they are saying 10 liter at HTP welding found to be 11.6 gram. This is there. So now what we can do, and we know, student, that is 22.4 liter of gas at STP will be how much, student? 22 point. This is the gas will be 44 gram, student. So how we can proceed here, student? 1 liter, if you are writing 1 liter of the gas at STP, it will be 11.6 upon 10. So 22.4 liter will be 11.6 upon 10 multiply by 22.4. So it is coming, student, 25.9 gram, or you can say 26 gram. This is gram per mole, right? So this is what is the molar mass, student. This is molar mass. Okay. Now another is empirical mass, student. Empirical mass, if you are calculating, this is CH. So CH 12 plus 1, that is going to be 13. So N equal to what is there, student? That is molecular mass upon empirical mass. So molecular mass is 26 and empirical mass is 13 is equal to 2. So now molecular formula is equal to N into empirical formula. N value 2, empirical formula CH. So that is C2H2. This is the molecular formula. Molecular formula is C2H2. So this is our required answer, student. Thank you very much for watching.